In this video, we are going to continue to look at the algebra of functions as we look at composition of functions. You may remember composition of functions from your previous algebra courses. That's when we are substituting one function into another. So given two functions, f and g, the composite, which is written f little circles g, also called the composition of f and g, is defined by f of g is f of g of x. So say f of x is the square root of x, and g of x is x squared plus 1. Then here, if we're going to substitute g of x into my f of x function, the x would go into the g function, which is here, and then that would go into the f function, which square roots it, and you'd have your x squared plus 1 underneath the square root of the f function. Let's look at it with these examples in number 2 here. Here, it says let f of x equal x squared and g of x equal x minus 3, and wants us to find f of g and g of f of x and their domains. Well, if we look at these domains, as you recall from before, none of them have restrictions. The function x squared is a parabola. It's going to keep going to the left and right with no restrictions. And x minus 3 is a line which will keep going to the right and left. So there are no restrictions on either of these. So our domain for the composite will not be restricted either. Now, if I find f of g, that means we're having f on the outside. Let's do g a different color. Let's go with blue. G will be on the inside. That's what it looks like when we do it this way. So my outside function is the x squared function. So I'm going to write that like that. This is whatever I'm putting into my f function as the input will go inside the square. That's what this says. Now what's going in there is my g of x function. So that would be, look like this. And we're done. Of course, you could multiply it out. If you did, you use factoring. And you get x squared minus 6x plus 9. But we also want to write our domain here, which is all reals. We could write it this way, or we could write it that way. Let's look at our second function here, which is g of f of x. Now, if g is my blue function, that here is going to be on the outside. So we'll write that like this. And we will be substituting the f of x function into it. All right, so outside we have the blue function, which is the x minus 3. Now, wherever the x is, I leave a parentheses to substitute in my f of x function, which in this case is x squared. F of x is x squared. So we just get x squared minus 3. That cannot be simplified any further. And our domain here would also be all reals. Let's do that with the values of 5 in part B. Well, we already found that f of g of x is x squared minus 6x plus 9. Or we could leave it in this form also, but I'll write it. What the heck? X squared minus 6x plus 9. But this is telling me to plug a 5 in. So wherever I have an x, I'm going to substitute in a 5. So 5, which will give us 25 minus 30 plus 9, or a negative 5 plus 9, which is 4. The second one, it wants us to do g of f of x. Oops, of 5. Do you think it's going to be the same value? Let's see. The g of f function we found to be x squared minus 3. So this will be 5 squared minus 3, or 25, minus 3, not the same value at all. Sometimes they are if they're inverse functions, but they weren't here. Now g of 5 would look like this. We'd substitute in g into the g function of 5. So as you recall, my g function here is, oops, that's not what I wanted to do, is x minus 3. So as we come back down here, what this wants is x minus 3, but so like that. Our inside function is x minus 3, and our outside function here is x minus 3. But for our x, we're substituting in 5. So we get 5 minus 3 is 2, minus 3 is a negative 1. Let's look at f of x. As you recall, our f of x function was x squared from above. So f of x my outside function here is x squared, and my inside function here is x squared. Remembering our exponent rules, that's going to give us x to the 4th. All right. In example 3, it wants us to pull apart a composited function. So it says if capital F of x is the 4th root of x minus 9, find functions f and g such that that function is really the composite of an outside and an inside function. So it just means pull it apart. So if I'm looking at this, what I would think would be my outside function would be the 4th root. And my inside function, I would say would be that x plus 9. So the way we write that is for our outside function, it wants us to call that f, because f is first. So we'd say f of x is the 4th root function. But I have to put an x in there. And my inside function, g of x, is the x plus 9. And that's it. You can check it by taking their composite. If we took their composite, my outside function would be the 4th root. That's this f. And the inside function would be the x plus 9. We put that where the x is here. And you can see that that's what we were given. So we decomposed this function that way. It's kind of an important concept because later we'll be using the chain rule where we'll need to be able to do that. All right, in our next video, we're going to look at transformations of functions. Thanks for watching.